Today, we'll be learning about Amazon API Gateway. In the previous videos, we learned about AWS Lambda functions and DynamoDB integrations with .NET. This time around, we'll build a couple of C# Lambda functions that basically can read and write data to DynamoDB, or in other words, a simple CRUD application on the cloud. We will then use Amazon API Gateway to create and manage a HTTP API that can expose these Lambda functions to the external world. We'll also explore a bit about CloudWatch for logging purposes. Hey everyone, I'm Mukesh from codewithmukesh.com, and this video is a part of my ongoing AWS on .NET playlist on my YouTube channel where we'll explore various AWS services and how we as .NET developers can get started with them. This is an AWS sponsored video. I assume that you already have an AWS account registered, but if you don't, you can sign up for the AWS free tier account. This is a very generous tier that allows you to experiment with various AWS services. I use this free tier account for all my open source work, articles and videos. Also, make sure that you have your development machine authenticated to consume the AWS services. I have made a video specifically where we authorize our machine with AWS credentials using AWS CLI profiles. Before getting started, it is recommended that you have a working knowledge of AWS Lambda and DynamoDB integrations with .NET applications. You can refer to my previous videos where we learn about these topics. Links are in the description. Let's get started with the basics. What is an API gateway in general? It's kind of like an API management tool that sits in between client applications and a collection of backend APIs, or essentially any source of data the client application needs. Amazon API Gateway is a fully managed service offered by AWS that empowers developers to build, develop, and manage APIs with ease. So whether you're a .NET developer or using any other programming language, API Gateway simplifies the process of creating RESTful APIs and connecting them to various AWS services like AWS Lambda or your backend system. Let's say that your application running on the internet needs access to the business logic that stays within an AWS Lambda. So these client applications would connect to Amazon API Gateway, which internally would redirect the request to the associated AWS Lambda or other services that you would have configured. Why would you want to use Amazon API Gateway? So it can take care of authentication and authorization for you, and it is pretty much easy to set up. It also helps you to monitor the incoming API calls and have access logging. It's also easy to set up rate limiting for your client so that you're not exploded with incoming requests. Caching is yet another feature to improve the overall performance of the system. It also acts as a single point of communication in a microservice architecture. Coming to the pricing part, being a fully managed serverless service as usual, you're charged only for your usage. So the free tier includes up to 1 million API calls per month for up to the first 12 months of your AWS free tier account. If you exceed this quota, you'll be charged around $1 to $3 for the subsequent 300 million API calls depending on the type of API use, that is HTTP, REST or WebSockets. So we'll talk about these API types later. So there are additional charges if you want to enable caching as well. Before getting to the implementation details, let's have a quick look at the AWS Management Console and see the Amazon API Gateway in action. To demonstrate this part, we will need to upload a simple Lambda function first. For that, let's build a simple C# Lambda that returns a hello world message. Let me open up my Visual Studio. Here, let's create a new project. I'll select AWS Lambda project and I'll name it hello world. And the solution name would be something like gateway demo. So once you create it, you'll be asked to select a blueprint. For this one, we'll just go with an empty function. Click on finish. So first up, you'll have to install the API Gateway events package to your Lambda function. So let me right click this project and click on manage NuGet packages. So here let me browse and search for API Gateway event. So this is the package that you got to install. So the current version is 2.6.0. Let's install this package. So I'll be building the same Lambda function about 3 times to show you the various features of API Gateway like query and path parameters. First up, I'll build a Lambda that just returns a hello world message without any input. For this, let me open up function.cs and I'll have to change the signature of this particular function so that it accepts this particular type of request that is part of the gateway events package. Let me rename it to request and return a simple message that says hello world. Adding to this, I'll also print out the request that we are sending from the API gateway via console.writeLine. So since it's a .NET object, we'll have to serialize this. I'll be using the JSON serializer for this. With that done, let me publish the function to AWS Lambda. So for this, I will just have to build this project. Once the build is complete, let me right click on Hello World and click on Publish to AWS Lambda. So if you're new to this entire AWS Lambda concept, I already have made a couple of videos around AWS Lambda, for which I will leave the link in the description. So let me click this Publish to AWS Lambda. Here, I'll have to give a name for this function. Let me name it Hello World. Let me click on Next. In this next screen, the only change you will have to do is to select the appropriate role. So for this, I'll be creating a new role that will be having something like AWS Basic Execution Role. So as you can see, this is the AWS Lambda Basic Execution Role. This is more than enough for our current implementation. Let me select it and click on Upload. So this should start building your project, generating the artifacts for your Lambda and uploading the Lambda to the AWS infrastructure. Let's give it a couple of seconds before it is completely deployed to AWS. So once the Lambda is uploaded, open up AWS Management Console and navigate to Lambda functions. So let me open up Lambda. So here is a Lambda that we just uploaded. Now, there are two ways to expose this Lambda function to the world. That is via a function URL of the Lambda itself and via Amazon API Gateway. So regarding the function URL of the Lambda, I have already mentioned that in the previous video. You can refer to it. But if you want to build and manage a set of APIs, API Gateway is the best option you have. So for this, let's search for API Gateway and open it up. Let me type in API Gateway and open it up. So this is the landing page of API Gateway, and you will be prompted to choose the API type you will want to create. So you have HTTP API, WebSocket API, and REST API. So these are the three major things. For this demonstration, we'll be continuing with HTTP API. Let's have a brief comparison about REST API and HTTP API. AWS supports three versions of API Gateway services. The initial release was for the REST API variant, which includes tons of features to design, develop, and maintain your API Gateway. Later, around 2019 something, AWS introduced HTTP APIs, which simplified the entire gateway creation and deployment. So do not get confused with the naming. Both of these versions are built on HTTP protocol following the REST conventions. Internally, AWS names them as V1, that is for REST API, and V2 for HTTP API. So what are the major differences between HTTP API and REST API? First up, HTTP API are meant to be better in performance and are almost 10 to 15% more performant compared to REST API. So the solo reason for this is that REST API has much more features compared to HTTP API. And in terms of pricing, the first 300 million requests per month, HTTP APIs would cost you just $1, whereas for the same volume, REST API would cost around $3 to $5. So that is a pretty huge difference at scale. Note that the AWS free tier includes 1 million API calls, that is for both REST and HTTP per month for the first 12 months absolutely free. So that's pretty enough time to explore both of these cool techs, right? The user experience offered by AWS Console while developing these gateways is completely different from each other. REST API supports edge-optimized endpoints, which ensure that your endpoints are highly distributed across the globe, while HTTP endpoints support only regional deployments, which might contribute to a slight delay in responses. Both of these are highly secure in nature. So for this demo, we'll be focusing on the HTTP APIs only. So over HTTP API, let's click on Build. Here, let me give the name of this API as Hello World and click on Add Integrations. As you see, the gateway can be integrated with HTTP, Lambda, and a couple of AWS services which we'll look later. So for this demonstration, let's select Lambda and select the Lambda that we uploaded recently, that is Hello World. Click on this and make sure that this is V2 always. Click on Next. So in this next screen, you get to choose your API routes. Let's make the method as get and the path to hello. So anytime we send a request to this particular URL, you'll be invoking this particular Lambda. So with that clear, let's click on Next. Next is the stages. So these are independent environments where your gateways can be deployed to. You can add stages like development, production or QA here, but for now we'll just proceed with default. Click on next. Now you can review your changes and create your API gateway. Let's create it. Now once the API gateway is created, click on this API part where you'll be able to get the URL of your stage. For now we have added only the default stage. So let's open up this particular URL and navigate to /hello. As expected, you can see the hello world message. So again, here is a brief of how everything worked. The client sends a request to the URL generated by API gateway, which can have multiple routes pointed to AWS services like Lambda and other HTTP endpoints. In our case, whenever there is a request to the /hello endpoint, the hello world Lambda will be triggered as per our configuration. If you see the code, the API gateway sends the request to Lambda as a specific object, which you have seen in the Lambda function signature, that is this one. So to understand this, I have already included a console.read line to print the incoming request to CloudWatch log of the Lambda. Let us navigate to CloudWatch and check the log group of the Lambda. So let's open up CloudWatch, log groups, and this is the specific log group of the Lambda, hello world. Let me open it up and open up a log stream. And let's open up this particular log. As you can see, here are the route keys, the headers and other metadata. Importantly, notice that the query parameters is empty. Similarly, the body and the path parameters is also empty. This is a nice way to understand the end-to-end functionality of Amazon API Gateway. To explore more, I'll modify the Lambda code, and this time, I want to also accept a name from the query string parameters of the endpoint. I already have the code handy with me. Let me paste it here and give a walkthrough. First, we define the name as an empty string initially and check if the incoming request is null. Also, I'll check if the request.queryString parameters is null. This is to handle if there are null values in the request. If they are not null, I'll try to get the name from the query parameters and feed it to the name variable. Next, I'll check if the name is empty. If it's empty, I will default it to John Doe and print out my message. Let's deploy. Let me build it once again. Once that is completed, right-click on the project and publish to AWS Lambda. Here, we don't need any additional configuration and simply hit on upload. Once deployed, let's open up our API gateway and get the URL. If I navigate to /hello, everything works like before, a simple hello message with the name John Doe. Now, when I pass a name to this URL, that is as a query parameter, name is equal to Mukesh, I get this message along with my name. So this is how you would pass query parameters via API gateway. Next, for path parameters, the only change in Lambda will be to read from request.pathParameters instead of query. So let me go back and open up function.cs, and here let me write path parameters. I'll do the same here. Let me build my application and deploy it. Back in our browser, let's go back to the new path parameter, that is hello / the name, which will be Mukesh. So why are we getting the not found message here? So this is because we have an entirely new route that is not defined within our API gateway specification. So for this, let's navigate back to our API gateway and create a new route. So open up your API gateway and hit on routes. So here, let me create a new route /hello, and we'll have to pass the name parameter here with curly braces. And let me change it to get and hit on create. Next, let's create a Lambda integration to this particular route. Hit on the get here and attach an integration. So here we'll just create a new integration. This will be a Lambda call, so Lambda function and our hello world Lambda. So we'll be giving this particular API gateway the permission to invoke this particular Lambda. Once that is done, review it and click on create. Now we have our API gateway route ready. Let's go back and refresh this. This time around, you can see that the name is being read from the path parameters as expected. For a better understanding, let me go to CloudWatch to show you the logs. So I'll go back to the log groups. I'll take the latest log stream and see this particular log. You can see this is our route key where we are having hello / name as the path parameter, which is actually filled by my name. And if you go down further, you can see in the path parameters object, you can see the name is equal to Mukesh. So now that we have understood the basic concepts, we will do a simple exercise where we will build a CRUD application as we mentioned in the beginning of this video. So to keep this video simple, I'll just add two functionalities to our API gateway, that is to create a new student and get the list of available students. So this will be two lambdas and one API gateway with two routes, that is post and get endpoints, which will be attached to the respective lambda. Additionally, we'll also use DynamoDB to read and write data from. Let's get started. So you can either have two lambdas for this use case or try to accommodate both the read and write operations within a single lambda. So how would you do it? It will be based on the incoming request. If the incoming request is of type get, the lambda will return a list of students from the database. If the incoming request is of type post, we will assume that it is a request to create a new student. In this case, we will read the incoming body from the request and try to create a new record in our DynamoDB table. So let's create a new AWS C# project in the same solution and name it as Student Manager. So let me select AWS Lambda project and name it as Student Manager. Let's create it, and again in the blueprint we'll just select empty functions and hit on finish. So once your Lambda is created, you will have to install the following packages, that is the API gateway events that we did in the Hello World project and the DynamoDB related package. So let me right click and manage the NuGet packages. Let's search for API gateway events. I'll install this. So once that is done, let me install the DynamoDB package. Install this as well. It is recommended that you watch my previous video about DynamoDB integrations in .NET for a better understanding. So once the packages are installed, let's create a student class. So right click on the project and create a new class at the root. Add new class. So let me name it as student. And I'll paste in the property for this class. As you can see, these properties already have DynamoDB supported attributes for the DynamoDB package to understand, which are DynamoDB table, DynamoDB hash key, and DynamoDB properties. So one thing to note is the hash key or the primary key of this particular table is going to be ID. So we'll look more into this when we navigate back to AWS Management Console and try to create a new DynamoDB table. So with that done, we'll make the changes to our function.cs. Let me paste in the code for student lambda function. So I'll just replace all this with my code. First up, since there will be asynchronous database calls, I have added async here for this method. And this function will return API gateway response. And similarly, like we saw before, this will be the same request signature. We will have to initialize the database connections using the client and the particular DB context. So as mentioned, there will be three scenarios handled here. If it is a GET request, that is this, so I'll be able to understand if it is a GET request or POST request from the route key. So if this particular route key contains GET space /, we'll assume that it is a GET key and we are trying to get a list of students. What it does is, using the DB context object, we'll scan the student database and get all the student data. And finally, we'll be returning this response and serializing the data to the body. So if the post request and the body is not null, I will deserialize the incoming request into student, and using DB context, I'll save this to my database. Else we'll simply return a bad request message. With that done, let's build this project and try to approve this Lambda using publish to AWS Lambda. So I'll just name this Lambda as Student Manager. And hit on next. So in the next step, we'll have to define a role for this particular Lambda. As you know that this Lambda should have access to DynamoDB and CloudWatch. For now, we'll give a basic execution role for this Lambda. We will add DynamoDB permissions once this Lambda is uploaded. Click on Upload. Once your Lambda is uploaded, navigate to AWS Management Console and open up your Lambda, that is Student Manager. Here, we'll have to attach the DynamoDB permissions to this Lambda. So navigate to Configurations and Permissions and open up your role, that is Lambda Execution Student Manager. Let me open this up in a new tab. So your IAM policies will get opened here. And as you can see, the current permissions that are attached to this Lambda is AWS Basic Execution Role, which contains this particular policies. So to this, let's click on Add Permissions and hit on Attach Policies. Here, search for DynamoDB. So for demonstration purposes, we'll just give DynamoDB full access for this particular Lambda. But in ideal production scenarios, be careful while using this permission. And hit on add permissions. Now, your Lambda should have the sufficient permissions to read and write data to DynamoDB. Now let's navigate to AWS Management Console and create a new student table under DynamoDB. So here, open up DynamoDB, hit on tables, and create a new table. I'll name it as students. Remember that this should match the exact name that we gave in the students class at the DynamoDB attribute. And as the partition key, we'll select ID and leave it as a string. So we'll leave everything else to the default and create the table. So give it a few seconds for DynamoDB to provision your tables completely. And once that is done, let's navigate to API Gateway. And let's use the same hello world with adding new routes to it. Let's open hello world and create a new route and say it as students. And firstly, for this route where we want to get a list of students, let's select the get and click on create. Now select this particular get endpoint of the students and attach an integration. So this time around, create and attach a new integration, and the integration type will be Lambda functions, and you'll have to select the student manager Lambda. So once that is done, ensure that you have granted these access and hit on create. With that done, let's go back to our API, get the URL, open it up, and navigate to the students endpoint. As you can see, we receive an empty array as a response. Now for demonstration, let's go back to DynamoDB, click on tables, open up the students table and add some dummy data. So I'll just hit on explore table items and create a new item. So here, let's give an ID of 1 and add a new attribute called first name. If you remember our student class, first name, I'll just add it Mukesh, and I'll add another attribute saying last name, and add another attribute of type number. The property name will be class and the value will be 10. Let's create this new item. So as you can see, the student table has one record. So let's go back to our API and refresh it. As you can see, our API is now able to return the data from DynamoDB. Now let's go back to our API gateway and create a new route to handle the post method. So I'll navigate back to Hello World API, hit on routes, and under students, I'll just create, it'll be of type post, students, and hit on create. We'll have to select the post method that we created and attach integrations. Create and attach a new integration. The event type will be Lambda functions, and the Lambda function will be student manager, and ensure that you have given the appropriate permissions and hit on create. Let's open a Postman to test the endpoint for creating a new student. Let me paste the URL of the endpoint and create a new body and hit on raw, press JSON. Let me paste in a sample request for this. I'll hit on beautify and ensure that you have this post endpoint selected and hit send. So as you can see, we have student with ID 2 created. So let's go back to DynamoDB to verify this. And let's refresh this particular table. As you can see, here is a new entry from Postman. So again, to verify, let's go back to our get endpoint and refresh this particular URL. And there you go. We have our API completely working. So to add on this, you can further modify the Lambda to support the delete and get by ID operations to ensure that it is a complete CRUD application on the cloud. Now that we are done with our exercise, I'll just give a brief walkthrough about API Gateway, about the additional features it has. So we have covered routes, and authorization is something that will need a complete video. So I'll be covering authorization in the next upcoming videos. So integration is already clear, and another important aspect of API Gateway is logging. So once you click on logging, select the stage that is default, click select, and as you can see, the access logging is disabled. Let's edit this and enable the logging. So this asks for a log destination, which is a new CloudWatch group. Let's go to CloudWatch and create a new log group. Hit on log groups and click on create log group. Let's name it YouTube/API gateway and give a retention settings of 1 day in case you forget to delete it. This is just an additional cost saving tip. Let's click on create. You can open up this particular API gateway log group and get the ARN. So we'll take that ARN and copy it here. And as for the log format, let's go with CLF. Once that is done, hit on save. So what this does is every time you have a request that is coming in, it will be logged into this particular log group, that is YouTube/API gateway. This will help you to additionally log all the accesses or invocations to the Lambda that is going via the API gateway. Another additional feature of API gateway to ensure that your costs are not exploding is the throttling feature. So hit on throttling, and here you can set rate limits for your clients. For example, in the default throttling, hit edit and set the burst limit and rate limit as 1. Let's save this and try to hit the API points multiple times. So I'll just press my F5 key for multiple times. So as you can see, this is how you can protect your API from DDoS attacks. That's all for this video. In the next video, we'll learn about authorization in Amazon API Gateway, where we'll try to secure these endpoints. So you can find the source code of this demonstration in this particular repository, the link to which you can find in the description. The source code of all the upcoming tutorials on my .NET on AWS series playlist will be available in this repository. Also, make sure that you always delete the AWS resources that you created once you're done exploring them. This helps reduce the cost incurred. Apart from that, to read the text version of this video, you can refer to this blog post. I hope you have enjoyed the video. Do not forget to like and subscribe to my channel for upcoming videos. Thanks, and I'll see you in the next videos.